Hey guys, welcome back to our second video on applying the definition of a derivative to find the derivative. Now, typically, there are three types of questions when you're in school that the teachers or the professors may ask you to find the derivative using this long process, okay? So one of them is for like a quadratic or a cubic, some sort of polynomial, and the second one would be for like a square root problem. So that's what we're gonna do today. The third one's gonna be like a function that is rational, which we'll do in our next video. So just a friendly reminder that the definition of a derivative is f of x plus h minus f of x over h, and don't forget the limit as h approaches 0, and that will find you the slope of the tangent line, okay? In this problem right now, I'm taking a look at f of x equals the square root of x. I drew a rough sketch of the picture. I emphasized 1, 1, 4, 2, 9, 3, and so on. But this is what the graph looks like. Okay. So let's find the slope of the tangent line for the function. So in order to do that, we're going to have to use the definition of a derivative. The first step is to find out what f of x plus h is. So every time you see an x, you're going to substitute with an x plus h. Now, we're going to take the limit as h approaches 0, and I hope you guys remember from the limits video how to solve limits that deal with radicals. If not, go back to the videos in the playlist. Okay, so this is f of x. Let me do this. This is f of x plus h. This is f of x. So f of x plus h minus f of x all over h, the limit as h approaches 0. If you try a direct substitution for h to be 0, you're going to get 0 over 0. So when we get 0 over 0, we have to rationalize, in this case, the numerator. So I'm going to go x plus h plus radical plus radical x over x plus h plus radical x. If you guys remember from the limits video, in order to rationalize conjugates, all you have to do is, in this case, this times this, and always with a minus in between. That's the shortcut. If you want to do it out using like your foiling method or your distribution property, please do. When you get to the bottom, we never, ever, ever multiply it. We're going to go h parentheses x plus h plus rad x, and I'll show you why in a minute. In the numerator, you get x minus x cancel out, and you're left with an h in the numerator. In the denominator, you get that h. Had you distributed that h, you would have not been able to cancel out the numerator. So now, this h and this h go out. That's a 1 on top. When you reapply this limit to 1 over x plus h plus the square root of x, then you get 1. Remember, h is 0. So you get radical x plus radical x. Well, 1 apple plus 1 apple is 2 apples. If I went too fast, pause the video and try to figure it out yourself and just see step by step, okay? Or leave a comment and I'll help you with it. But right now, the slope of the tangent line for this function is this guy here, okay? 1 over 2 rad x. So in this here, it says, what is the slope of the tangent line of the function, this guy here, at the following points? So first thing is, f of x equals radical x. I just figured out what f prime of x is. F prime of x, again, is the derivative. And that was 1 over 2 rad x, okay? So now that we have that, we're able to find the slope of the tangent line at these points by just substituting these x values into the derivative. So the slope of the tangent line of f prime of 1 is equal to 1 over 2 rad 1. So that's 1/2. 1 over 2 rad 4. So that's 1/4. 1 over 2 rad 9. That's 1/6. What that means is, let's say for 1/2, that means you go up 1 over 2. For 1/4 means you go up 1 over 4. And then up 1 over 6. So you go like that slope, that slope, that slope. Okay? So that's how you do that. But let's take a look at it on the picture. So that slope, that slope, that slope. And that's how you find the derivative. This is how you find the derivative. And this is by using the definition of a derivative. Remember that This is the notation for a derivative once you find it. And remember, it's the slope for every place. And if you want a specific point, you just plug in your x's. Okay, and that's how you do the derivative for this guy. Remember, since you're applying limits and you have radicals, to make sure that you rationalize the numerator and make sure you never distribute the bottom. Have a great day.